Hello everyone, this is section 1.3, which is about applications and problem solving. And so we are dealing with a lot of word problems here. And as the introduction says, the objectives are to solve applied problems by translating to equations and to solve basic motion problems. So word problems are the things that a lot of people are not excited about. And one of the reasons is that you really have to think everything through. It's not simply applying some formulas and then we come up with an answer. It takes some understanding of the problem statement and also determining a path, some kind of a strategy to get to an answer. And so even though every problem is a little bit different, there are 5 general steps for problem solving. And the first one is familiarize yourself with the problem situation. Step number 1. Well, what does that mean? Well, that means you need to read the problem statement until you understand what it's about and what the question is. And if you happen to have paper available, maybe write down what the question is so it's clear in your mind what you're supposed to determine. That is an important part. How many times should you read the problem statement until you get it? That could be 1 or 2 or 5 or 10 times. And just to let you know, even for me, I've done a lot of these problems. When I see one I've never seen before, in many cases I have to reread the problem and ask myself, what is the question here? And then determine a way to get to the answer. And one of the important things here is point number 2, to translate the problem to an equation. And that is where a lot of people are challenged, because again, that just takes some practice. Point number 3, solving the equation most of the time is not the real problem, and then checking the answer in the original problem. That of course makes only sense that you do that. And then state the answer to the problem clearly. That's usually not a big challenge either. But number 1 and 2 is usually where the challenges come up. So, but there's a little bit more to it, and so let me give you some more explanations about it. So here are some hints. To familiarize yourself with a problem, if a problem is given in words, and it usually is, read it carefully. Good advice. List the information given in the question to be answered. Choose a variable, or maybe more than one, to represent the unknown quantities, and clearly state what the variable represents. Be descriptive. For example, let L, length, be in meters, in other words, a unit of measure. Or D might D might be distance in miles, and so on. So be specific what the unit of measure is. That turns out to be a pretty important aspect. Then make a drawing if you can, and label it with known information. Also indicate unknown information using specific units if given. Then find further information if necessary. Look up a formula at the back of the book or in a reference book. Look up the topic using internet search engines. There are many ways to approach this. And then make a table that lists all the information you have collected. Look for patterns. Sometimes they help you translate the problem statement into an equation. And then think of possible answers and check the guess. Note the manner in which your guess is checked. This will help you translate the problem to an equation. And last but not least, when you think you have a solution, calculated or not otherwise in particular, then you want to ask yourself always this question: does my answer make sense? And in my years of experience, I've seen a lot of solutions to word problems where the answer was absolutely nonsensical. And so you want to make sure you don't come up with an answer like that doesn't make sense. Is it even in the ballpark? Does it even make sense? So always ask yourself that question at the end. Then I have some suggestions for you. Of course I would. That's why I'm your instructor. Number one, to get good at word problems, you must do many of them. You will get better. It may take very long in the beginning, but eventually you will get better. And so I recommend to start out with the word problems, work through every example in the book. And so that will help to get your mind thinking correctly. So every example in the book, see if you can redo it yourself on your own, or at least follow it step by step and understand what the transition is from one step to the other, why it's being done and what is being done. And so here, point number 3, I made that earlier. One of the challenges of word problems is that you must think everything through. And that's unusual for many people because, we are used to, get information in small bites, and we don't have to think much about it. And that's a little bit different here in word problems. You have to think it through. And number 4 is don't give up on yourself. You will get better at this, provided you keep working and developing your thinking skills, as well as your math skills. So it's thinking and your math skills that need to be developed here. And that only comes from practice. And then last but not least, know that you have what it takes, but you probably need a lot of practice. And this is true for most people, including me. We were not born with these abilities to do word problems and just like that. Most people need to work on this for a while. And again, the key to it is to do lots of word problems, and I would guarantee you will get better at it. Just keep on going. As I mentioned a moment ago, I will not be going through the examples in the book because I really feel you need to do that yourself. You've got all the information, you've got the numbers, you got the right you got the complete answer and everything else, and you need to develop the practice of doing it. But what I will do is I will do some of the exercises from the book, and one of them is this. It's about population increase. From 2015 to 2016, Texas gained 432,957 residents. This was 13,451 fewer than 4 times the number of residents gained by North Carolina during the same time period. So how many residents did North Carolina gain? So in this case, the question is very obvious, very simple, but I still highlighted it. How many residents did North Carolina gain? So we can begin by saying, okay, what's the question? Well, R, let's say that's the number of residents. North Carolina gained from 2015 to 2016. So there's our variable, our unknown, that we want to know what that number is. Now, it talks about 4 times the number of residents gained. So there would be 4 times R, 4 times the number of residents gained. But that's 13,451 fewer than 4 times gained. So in other words, that means we subtract because it's fewer. 13,451 fewer than North Carolina gained in the same time period. And so that's this, and Texas gained that many residents. So that's equal to the number of residents that Texas gained, 432,957. Okay, so this is a simple equation that we know how to solve. We add 13,451 to both sides. So that means then 4R is equal to 466,408 and then we divide both sides by 4 to isolate r, the variable that we want to know. So then r is equal to 111,602 residents. 111,602 residents. A very simple little example of how to solve a word problem, and you may want to go over that again on your own and see if you can come up with the same answer. But this is our answer. Now, the complete answer would be, of course, that the number of residents that North Carolina gained from 2015 to 2016 was 111,602. So again, write out the complete answer. The next example is about the cross-section of a roof. And here's a problem statement. In a triangular cross-section of a roof, the second angle is twice as large as the first, and the third angle is 20 degrees greater than the first angle. Find the measures of the angles. Again, I chose to highlight the problem statement to make sure we come up with the answer that's required here. So since this involves geometry, we read about a triangular cross-section of a roof, so we're dealing with angles. So let's draw a little sketch here of what that might look like. So here's our triangle representing the triangular cross-section of a roof. And we arbitrarily label this angle 1, and this angle number 2, and this angle number 3. So we are told that the second angle is twice as large as the first. So if the first, let's say we call the first angle x, the measure of the first angle is x. So it's the measure of the first angle. Then we know that 2x is a measure of the second angle. And we are told that the third angle is 20 degrees greater than the first angle. So if the third angle is 20 degrees greater than the first angle, that means then x plus 20 is the measure of the third angle. So far, so good. Now, we also need a little bit of information about the sum of the angles of a triangle. And you may remember that the sum of the interior angles of a triangle equals 180. That's an important piece of information. And that information is actually in the back of your book. And you can find it right there under geometric formulas. For a triangle with angles A, B, and C, or 1, 2, and 3, the sum equals 180 degrees. Therefore, we can write the following equation. X, the sum of, the measure of the first angle, plus 2x, the measure of the second angle, plus x plus 20, the measure of the third angle. The sum of the three angles has to equal 180 degrees. Now, I didn't really have to write the third expression in parentheses, but I really want to separate it out as the measure of an angle here. So let me rewrite this without the parentheses, because we don't really need them, since they are preceded by plus sign. So we can write this as x plus 2x plus x plus 20 equals 180. By collecting like terms on the left side, we get x plus 2x is 3x plus x is 4x, 4x plus 20 equals 180. And we know how to solve this little equation here. We subtract 20 on both sides. So then 4x equals 160. And then we divide both sides by 4. So that means that x is equal to 40 degrees. Now, in some cases, I've seen that people stop at this point, even though they have an essential part of the answer. It's not the complete answer. Remember, the question is, find the measures of the angles, all of them, not just one of them. So, therefore, we say x equals 40 degrees equals a measure of the first angle of the first angle and remember the measure of the second angle was 2x, so then 2x would be equal to 2 times 40, or 80 degrees would be the measure of the second angle. And x plus 20, which would be 40 plus 20, would be equal to 60 degrees, and it would be the measure of the third angle. Now let's check our work. Remember, the sum of the interior angles of a triangle have to equal 180 degrees. So let's ask our question, is 40 degrees plus 80 degrees plus 60 degrees equal to 180 degrees? Is that true? Well, 40 plus 80 is 120, plus 60 is 180 degrees. The answer checks. Or the answers check. So now we are sure that we have the correct answer with these statements here. This example about real estate commission is similar to example number 4 in the book. And so here somebody negotiated a realtor with a realtor who sold a house for the following commission. So the deal is the realtor earned 7% for the first $100,000 of the selling price and 5% for the amount that exceeded $100,000. And then the realtor received a total commission of $13,400 for selling the house. So the question is, what was the selling price? So in other words, that is what we want to know. We're going to highlight the question here. What was the selling price? So let's call the selling price X. That's a nice variable to use in many cases. So let's say X is the selling price of the house. And now let's think about what this information means that we have here. So we know the realtor received 7% for the first 100,000. So 7% would be the same as 0.07 in decimal format times 100,000. Also, the realtor will get 5%, or 0.05, times the amount that exceeded $100,000. Now, the amount of the house, or the selling price, would be X. So, in other words, we have X minus 100,000. So that's the statement for the 5% for the amount that exceeded 100,000. Okay, and that has to equal the total commission, and that was equal to 13,400. So that equals 13,400. So that's our defining equation here. And as I mentioned in the beginning, solving the equation is usually not that big a problem. You know, we multiply 0.07 times 100,000, so that would be 7,000. And 0.05 times x is 0.05x. And then 0.05 times 100,000, that would be minus 5,000. And all that equals 13,400. We combined like terms on the left side, so that gives us 0.05x plus 2,000 equals 13,400. And since we have solved lots of equations of this type, we subtract 2,000 on both sides. That means we have 0.05x on the left side, and then 11,400 on the right side by subtracting 2,000 on the right side. And then x would be equal to 11,400 divided by 0.05, since we want to isolate x. So 0.05. And therefore, concluding the calculation here, x would be equal to $228,000. So in other words, the selling price of the house was $228,000. Selling price. Okay, so you may want to think about this a little bit. What most people have a little trouble with is about the the amount that exceeded 100,000. So you may want to give this expression some thought. But when you really think about it, whatever x is, obviously it has to be greater than 100,000. So that would be the difference between 100,000 and what it sold for. And that's how we actually compute our variable x, 228,000. The next example is similar to example number 7 rather. Refer to example 7. The artist saves 3 other prints for her own archives. These are also numbered consecutively. The sum of the numbers is 1,266. Find the numbers of each of those prints. Well, what does it mean numbering consecutively? Well, here's an example of 3 consecutive numbers. 12, 13, and 14. These are 3 consecutive numbers. That's what's meant by consecutive numbers. Now notice that we can write that also as 12, 12 plus 1, and we can write it as 12 plus 2. Okay? So in general then, if we don't know what the numbers are, we can use x, then x plus 2 would be the next number, and x plus 2 would be the next number. So here we have 3 consecutive numbers. Okay? So that's the idea behind it. And understanding that now, then the solution becomes pretty obvious, because it says here, the sum of these 3 consecutive numbers is, or equals, 1,266. That means we add up these 3 numbers. So what does that look like? Well, we add x plus, and I make it more obvious by using parentheses. We don't really need them, but x plus 1 plus x plus 2. So these 3 numbers need to add up to 1,266. So, and as I said earlier, setting up the equations is usually where the time goes. So I began in a very simple example by explaining what consecutive numbers are in a particular case, how we can rewrite them, and how we can write 3 consecutive numbers in general. And here's the sum of 3 consecutive numbers that add up to 1,266. So we can drop the parentheses since they're preceded by plus signs. So we can write this expression as x plus 1 plus x plus 2 equals 1,266. So we collect like terms. So x plus x plus x is 3x. And 1 plus 2 is 3. And that equals 1,266. And again, we know how to solve a simple linear equation like this. We subtract 3 on both sides, and that gives us 3x equals 1,263. And then we divide both sides by 3. So we divide both sides by 3, so x equals 421. Okay. Now, are we done? No, because the question was find the numbers of each of those prints. We found one of them, so now we have to find the other one. So, but that's easy, because the next number would be x plus 1, so it'd be 422. And the next one after that is x plus 2. So it'd be 423. So then the 3 consecutive numbers that we are supposed to determine are 421, 422, and 423. And then we can check our answer by adding up these 3 numbers. In other words, the question is 421 plus 422 plus 423 equal to 1,266? And the answer is yes. So this is our solution to this particular problem. here is the all-important motion formula. Distance equals rate times time, or speed times time, or d equals r times t. And you probably used that before, indirectly or directly. That is, if you know you can average, 60 miles per hour, and so if you can drive for 3 hours, then that means you will have traveled 180 miles. Or, on the other hand, maybe you're driving down the freeway, and it says to your destination city, it's 240 miles, and let's just say you can average 60 miles an hour, then you divide the distance by the rate, and then it'll tell you it'll be 4 hours worth of travel. So that is a very, very basic equation, and we'll be using it many, many times. In fact, we'll be using it right now. So that's about marine travel. So Tim's fishing boat travels 12 kilometers an hour in still water. How long will it take him to travel 25 kilometers upstream? If the river's current is 3 kilometers an hour, and how long will it take him to travel 25 kilometers downstream if the river's current is 3 kilometers an hour? Well, you know intuitively that when you travel upstream, you go more slowly. We have to subtract 3 kilometers an hour from our travel speed in still water of 12 kilometers an hour. And on the other hand, when we go downstream, we go faster because we go with the current. So that's an experience that many of you have had. Okay, so here we need to find, the question is, find the speed of the boat in still water. Oh no, we know that, I'm sorry. So let us define our variables here. Let's say that r sub u is the upstream speed, would be 12 minus 3, or 9 kilometers per hour. That's our speed going up, or his speed going up the river. And so since d equals r times t, and we want to know what t is, so we know, and d is equal to 25 kilometers, we can write this now as 25 we're going upstream now, equals 12 minus 3 is 9 kilometers per hour times t. By dividing both sides by 9, we find that t is equal to 25 divided by 9, which would be 2 and 7/9 hours, 2 and 7/9 hours. And that's not really a very useful number. So, but we can say that's approximately 2 hours and 46 minutes, or 47 minutes. We round it up to 47 minutes. So it's approximately 2 hours and 47 minutes. That's 2 and 7/9 hours, and then it would be more useful divided this way. And how do we do that? We divide 7 by 9 and multiply by 60, and that'll give us the minutes. So that's for going upstream. Now going downstream, we find our rate of travel, our speed, r sub d, would be 12 plus 3, or 12 kilometers per hour. And we use the same formula, d equals r times t. So now for upstream we have 25. The distance is of course, downstream is of course the same distance, talks about 25 kilometers downstream, equals 12, our speed, times t. 15 times t. Sorry about that. 15 times t. And so we divide both sides by 15 to isolate t. So t is then equal to 25 divided by 15, and that's 1 2/3 hours. Again, that's okay, but it's not all that useful. It would be nicer to write this as 1 hour and 40 minutes. Most people don't think in thirds of hours or anything like that, but we can think in terms of minutes. So always think about the user. So that's for the downstream travel. So it's about an hour's difference. Even though the speed of the river isn't all that great, only 3 kilometers an hour, but it makes a difference going up versus downstream. The last example I want to share with you is a little bit different. It's not out of the book, but it's about a different approach. So here it says 2 cars, initially 360 kilometers apart, begin driving towards each other on a long straight highway. One car traveled 80 kilometers per hour and the other one 180 kilometers per hour. At the same time, a canary starting on one car flies back and forth between the 2 cars as they approach each other. If the canary flies 120 kilometers per hour, that's a pretty fast canary, and spends no time to turn around at each car, how far has it flown when the cars collide? So let's draw a little picture of what this actually looks like. So here I sketched it out for you. Here's the one car that travels at 80 kilometers an hour in this direction. And on the other side, on the other end, is the other car traveling 100 kilometers in the opposite direction. And here's our canary that flies at 120 kilometers an hour. And of course, we can use our formula, D equals RT, to determine for the bird, for the canary, to fly back and forth. And of course, the distances between the cars will diminish, back and forth until the cars kind of crash head on. Let's say they avoid that. Anyway, that's the idea. Now, that's a pretty complicated formula, and not to say it can't be done, but it really requires math beyond the scope of this course. So if you think about it in a little different terms, you can ask a different question. What if I looked at it from a standpoint how long it takes for the bird to fly? How long does the bird fly? In other words, how long until the cars meet? Well, if one car drives at 80 kilometers an hour times some time t, and the other car drives at 100 kilometers an hour, same time t, because they're going to meet, they have to travel a distance of 360 kilometers. So in other words, 180 t equals 360 kilometers. And then t would be equal to 360 divided by 180 kilometers an hour, so that would turn out to 2 hours. Okay, so in other words, after 2 hours, the cars meet. And that's exactly the time that the canary spends in the air, flying back and forth. And since the canary flies at 120 kilometers an hour, we simply now multiply d, the distance the canary has flown, which is equal to its speed of 120 kilometers an hour, times the time it flew, 2 hours, times 2. So in other words, the canary has flown a distance of 240 kilometers. And the reason is the distance the canary has flown. When the cars meet. let's assume they can avoid crashing, okay? But the main reason I threw in this example is because sometimes you just have to take a different approach to a problem and be creative in your thinking. So that'll be the last one for section 1.3, and soon you'll get a section 1.4.